So this problem says find the magnitude of V. So what we're going to do first is we're going to create the standard position vector for this vector V we have here. So think about what that means. That means I'm going to take this point here, which is the initial point, and I'm going to move it to the right and up so that it's here at the origin. So let's see. What that means for us. So that means I'm going to move to the right 5. So in a way, I'm going to add 5. And I'm also, for my y value, going to add 10. So that's what I'm going to do with my initial point. So I'm going to do that same thing with this terminal point. Okay, whatever value that is, I'm going to move that to the right 5. So 1, 2, 3, 4, 5. And then I'm going to move it up 10. There's 4, 5, 6, 7, 8, 9, 10. So let's just kind of see what that looks mathematically now. Just algebraically, excuse me. So for my points, I'm going to get -5, -10 for my initial point, and for my terminal point, I'm going to get -7, -4. So now what I'm going to do is I'm just going to think about what I'm actually doing there. So I'm going to, remember what I said, move to the right 5, and then in my y direction, I'm going to move up 10. So +5, +10. Now notice what I'm going to do here. I'm going to just take this terminal point, which is -7, -4, and I'm going to subtract the initial point. And by doing that, notice what happens here. This is really a -7, and I'm going to minus a -5. So in doing that, that's going to give me really a +5. So I'm going to get actually a -2. And then I'm going to do the same thing with the y value. So I have a -4 here. So I'm going to subtract a -10. So that's really adding 10. So that's going to actually give me a +6. So that's actually going to be the standard position vector here. So now I'm just going to think about this geometrically, and I want you to kind of see this. So that means if I move this over 5 and then up 10, I do the same thing with my initial point, or my terminal point here, which is here, that -7, -4. And I'm going to move that over 5, so that's going to be there. And then I'm also going to move it up 4, 5, 6, 7, 8, 9, 10. So it's actually going to put me right here. Now, if you look at my standard position vector, that's going to be -2, -6. And if I go over 2 and up 6, notice where that puts me. That puts me right where I need to be. If I think about this even geometrically, that should complement the math. So that means my new vector then is going to be this -2, 6. And again, that makes it an easy way to find it without graphing it and everything else. I can just take this and take my terminal point and subtract my initial from it. And that'll give me my position vector, standard position vector. So there it is. So now what I'm going to do is I'm going to talk about the magnitude of V. Now again, I didn't have to go through all of this in order to do it, and I'll kind of show you the formula to find the magnitude. And essentially I'm taking the initial point and the terminal point and setting them up in a similar way. And you'll see how that kind of works out for us. But from here, knowing that my vector now is -2, +6, to find the magnitude of this, we can think of the idea of a triangle here. And if I look at that triangle, all I really need to know is this side here, which is -2, and this side here, which is 6. And I can actually find this magnitude now. Okay, so that's really just going to be these values that we see here, correct? Yes. So therefore, all we really have to do then to find this magnitude is take, now look at the notation I use here. Sometimes we can see a double bar here for this, and that means magnitude as well. So this is going to be the square root of negative 2 squared plus 6 squared, all square rooted. So that's essentially what that's going to be to compute that. And again, if you think about the Pythagorean theorem here, this is really my negative 2, that's my 6. I square those and square root it to find this side. So that's really what we're doing here. That's where it comes from. So anyways, our answer becomes square root of 40. But again, that's not enough for us because we're Calc 3. We should simplify this even more. So notice 40 has a factor that's a perfect square, which is 4. So I really have the square root of 4, which gives me 2 square root of 10. So that's actually the magnitude of V. Now I just want to let you know, if you look up any general formula for any vector anywhere, not necessarily a standard position vector, what you'll notice here is they just take the square root of, and this is something I want to show you here, they take the initial x value minus the well, I should say the terminal x value and the initial x value, and then we square those, plus, oops, I didn't make that far enough, and that's going to be 7, yep, so negative 4 minus a negative 10 squared. And that's essentially what they do to find the magnitude of any vector. And that's the formula you see. Now notice what we did here. We did take the negative 7 and subtract the negative 5. And that was that piece there. And notice what number that was. That was at negative 2. Okay, and then we did the same thing with negative 4 minus negative 10. And that's what this is here. And that gave us the 6. So we see that we actually went through that process. And then what did we do? We squared them. And then we square rooted them. Now notice what we have here. See, those are these values here, squared and square rooted. So I'm not doing any more work by doing this. Essentially, when I get in a standard position vector, I kind of have to do that anyways, and that's what this first step is here. So just kind of keep that in mind as you go through this. Yeah, it's a formula. Is it any faster? No. Now to do our next problem, our vector W is here. So now we're going to just find the initial and terminal points, and those are negative 6, 1 for the initial point, and for the terminal point, negative 2, 3. So in essence, we can just handle this the same way. We could move this to the center, and that makes it so much easier when we're actually dealing with doing any sort of computation with these vectors. So that means I'm going to take this negative 2, 3, and I'm going to subtract this negative 6, 1. And that's going to give me my vector in standard position form. Oh, I did 4, 3. Bummer. Glad it caught it. So the formula for a unit vector then is going to be, the unit vector simply means, before I get into the formula for it, means it has a magnitude of 1. So we want it to be in the direction of W there, but it has to be a unit of 1. So in order to do that, essentially what we do is we take our vector, and now our vector is 4, 2, which you see, and it took me forever to draw it. It's going to actually be over its magnitude. So think about what I did here. So if I take a vector and I divide it by its magnitude, so whatever number or magnitude this is right here, and I divide it by the magnitude, that's going to give me 1. So that's why I divide it by its magnitude. And the magnitude of W is 2 square root of 5. So again, there's the math for that. So now all I'm going to do up here is, now keep in mind this is going to be my unit vector. So that unit vector then is going to be 4 over 2, or 4 comma 2 over, 2 root 5. So I'm just going to divide that into both of those. And for my final answer, I'm going to get 2 over square root of 5, comma 1 over square root of 5. Now kind of keep in mind here, this 2 cancels with the 4 and also with the 2 here. So with the 4 it leaves a 2, and with the other 2 it leaves a 1. So I get a 2, 1 here over root 5. So here's our final answer for the unit vector and the direction of W. Now if I graph that, you would see that it would end up right on this vector here, but it would only go out a unit of 1. So there it is.